Since e to the x is 1 to 1, continuous and increasing, it must have an inverse. But there's no way to solve x equals e to the y for y, so we must define the inverse of e to the x, and the inverse of e to the x is called natural log, written as f inverse is ln x. So that x equals e to the y and y equals ln x must be equivalent. In general, if f of x is equal to a to the x, where a is greater than 0, then the inverse is log base a of x, so that x equals a to the y and y equals log base a of x must be equivalent. Log base e of x, natural log, is the log with base e. So log base e of x is the same as natural log of x. Log base 10 of x is the common log, so writing log of x with no base automatically means base 10. Use a calculator to graph ln x and log x on the same coordinate plane. Do you see any similarities in the graphs? Similarities that I see between ln x and log x are that they have the same x-intercept, they have a vertical asymptote at x equals 0, and they are consistently increasing and concave down. Graphs of logarithmic functions: if you are graphing log base a of x where a is greater than 1, your domain will be 0 to infinity and the range will be negative infinity to infinity. You have a vertical asymptote. The graph of f of x is continuous and concave down, 1 to 1. It has an inverse and the x-intercept is 1, 0. Without using a calculator, sketch a graph of y equals the absolute value natural log of x minus 2. Write an equation for the graph's asymptote. It might be difficult to graph this, so I'm going to start with just graphing the parent graph ln x. Now I'm going to translate that 2 units to the right. And now I'm going to take the orange graph and make it absolute value. So any y values that are below the x-axis should be reflected to be above the x-axis. That pink graph is our graph.